on
Is this
electrodes,
form on the electrodes?
change in colors of solution,
And there's one more.
deposits of metals will be formed on electrodes.
Very good, right? So deposition of metals onto the electrodes. Very good. Okay, can you quote one example of the color change? Quote one example of the color change in terms of chemical effect of electric current. Yes, it's a food and it is rich in starch. And it's a modified stem also. You know, it has eyes also. Which food is it? Which vegetable is it? I'm asking for the example of the color change. Potato, right? Okay. So when you connect it with the wires, so you will see that at one side, the color would be changed, turning bluish green, as you can see here. Okay, no? Potato has eyes. What does it mean? Not the actual eyes, but they have the eyes from which the birds grows. Birds grows and a new plant grows anyways. So let's continue from here. Electroplating. Okay. So electroplating, it's simply one such example. It is one of the example of the chemical effect of electric current. And this process is useful as it will be helping us in protecting the metal object from corrosion. It will give a shinier appearance to that metal object, will improve its durability. Getting it now? Will be basically preventing it from corrosion. So let us understand like how it will be done. I suppose by now you should have all, you guys must be already familiar with the concept of electrodes, ions, and electrolyte. If there's any question, please let me know. No questions? Good. So let us understand. Take the example of this copper, like we are going to deposit a layer of copper on the brass. Brass, you guys understand now? Bells are made up of brass. So many things are made up of the brass. Okay.
Yeah.
So Ramesh, Vaiga, for example, if you were to go to the temple, for example, if you were to like we were to go to any temple, so there the temple particularly we see that the bells are made up of brass particularly, not of the iron, because iron rust easily and the brass does not rust easily. Anyways, getting back to the topic of electroplating. So if you were to deposit a layer of copper on the brass, so what are the things we are going to do? The first thing is that we're going to take the right electrolyte and the electrode. You have to take the right type of electrolyte and the electrode. Getting it now? So the first electrode should be the copper, and that will be anode. So the metal that is going to be used for electroplating has to be made anode. Okay. And the one over which deposition of the metal has to be done, that will be the cathode. Got it? That is first thing. Another thing is that you cannot take any random electrolyte now. The electrolyte that we are going to use here must have the metal that is going to be used for electroplating. I repeat, the electrolyte that we are going to use here must have the metal that will be used for electroplating. Are these points clear so far?
Yeah.
Okay. So Vaiga, read from here to here. Read the first and the second point.
Okay, sir. In order to conduct electroplating, right electrodes and electrolytes must be chosen so that metal can deposit over a material. For instance, if we want to deposit copper on a material, we need an electrolyte that contains copper in it. Similarly, we need gold on a material. We need an electrolyte that contains gold in it.
Good. So that is the case. Next, as soon as the electricity will be passed through this, as soon as the, also one more important thing is there. See, we need to show that there is not any unwanted substance on the electrodes. The electrodes are completely clean. Okay, now if it appears as if the electrodes are not clean, so we need to make sure that it is clean. We can either use a sandpaper or some other clothes can also be used to clean it, basically, right? Okay, so after having cleaned the electrodes, we are going to turn the switch on. Basically, the flow of electricity will occur in this. Now, when this electricity will pass through this, what is going to happen? Tell me. When the electricity will start to flow via the electrodes into the electrolyte, what will be the first thing going to happen? There will be some breakdown, some chemical breakdown is going to happen, isn't it?
Yeah.
So which thing is going to break here into its components?
Copper. No.
Electrolytes. Now, first
Yeah.
electrolytes are going to break. Okay, electrolytes are going to break, plus the copper from the anode from this copper electrode is also going to break away, because we are simply transferring the copper from this rod to the another rod. The copper from this anode is also going to break away, plus the electrolyte is also going to split up into its component. So electrolyte here, since we are doing the deposition of copper over the brass, so the electrolyte must contain copper. So we have taken a metal, taken the copper sulfate in here. Getting it, everyone?
Yes, sir.
So copper sulfate is now going to split up into cations and anions. Okay. So
Can you
copper's,
explain it again?
yeah, I'm going to write it over here. That will be better clear. Okay. So you have, yes, Ibrahim, how are you?
Fine, sir.
Good. Copper sulfate, when electricity passes through this, it is going to split up, break down into the components. So it breaks up into cation and the anion. Copper here is the cation. Getting it? Copper is the cation and the anion is the sulfate. SO4 2 minus, that is the sulfate. Let me write it in words also. That is the copper and that is the sulfate. Now is it clear?
Yeah.
Good. Now, as we know that the copper is anode while the brass is the cathode. So copper being positively charged will obviously be transferred towards the, will be traveling towards the cathode, that is the negatively charged rod, isn't it?
Yes, sir.
So in the given animation, you will observe that how the copper ions are moving towards this cathode. That is one thing. Plus, plus we are seeing that the copper from this anode is also going to break away. Okay, na? So when this experiment will be done, so whether it takes 10 minutes or 30 minutes or a complete day, at the end of the experiment, the copper anode will become very thick, very thin, I mean to say. Why? Because all the coppers have been now deposited over the brass. So copper will be will be breaking away from here also, and will be going into the electrolyte, and then further will go into the cathode. So that is the whole method of electroplating. If there's any question, let me know. If not, then Ramiz, we're
Sir,
going to. Mhm.
can you explain it again?
Yeah, sure. From the beginning.
Yeah.
Okay, no issue. See, about electroplating, what we have learned. It is the deposition of metal from one rod to another, right? From one rod to another. Suppose this here is the copper rod in my hand. This one is the brass rod. Now I need to do a coating of copper onto the brass rod. So for that purpose, I have made the copper as the anode. The metal that is going to be used for electroplating here, that is always made the anode by connecting it to the positive terminal of the battery. Okay. Then the metal or the object over which deposition of metal has to be done is always made.
The negative side.
What do we call that?
Um, cathode.
Cathode. That thing is clear.
Yeah.
Next, as the electricity will flow into the electrolyte, so electrolyte is going to split up into positive and negative ions, namely in the cations and the anions. In this case, it's copper sulfate, so it will be splitting up into copper ions and sulfate ions. Copper and sulfate. Is that thing clear so far?
Yeah.
Okay. Now, there's the use of this copper rod now here. Like why we are using this copper rod here, huh? So what is the use of this copper rod? That the copper will break away from this rod also. Slowly, the copper ions will be breaking away from the anode and it will dissolve into the electrolyte. And those coppers are also going to deposit over the brass, since brass is negative here, negatively rod. Getting it? So that
Yeah.
is the whole process of electroplating. So you continue to read from here, not from there, from this point here, the one where I'm pointing. Read this quickly. Yes, Ramesh, you're supposed to read.
Okay. The electrodes used are made up of different materials. One of the electrodes is of the same material of which the electrolyte solution is. The second electrode needs to be the material on which we want to put the other metal. For instance, in case we want to plate metal, when we want to plate copper upon brass, one electrode should be of copper and the other electrode should be of brass, and the electrolyte solution should be any salt that contains copper in it. For example, copper sulfate solution. Consider the diagram given below that describes the process of electroplating of copper.
Okay. So that was the whole thing over here. Any questions from this
Awesome.
to anyone else?
No, sir.
Okay. So that is the thing over here. Then talking about like what are some of the applications of this? So there are various applications. One such application you have learned that you can deposit a layer of copper on the brass. Or suppose, for example, I have a spoon. Okay, now I have a spoon in my hand, suppose, and I want to make it very shiny. I want to deposit a layer of silver on it. So there also electroplating can be used. Getting it? Or suppose, for example, I have to deposit a layer of gold on this. So there also I can use the process of electroplating. Getting it now? So there are various applications, particularly certain examples, applications are such that it is basically used in the industry for coating metal objects with a thin layer of a desired metal. Suppose in my hand I am having iron. This is made up of iron. Suppose it is not very shiny. In order to give it a shinier appearance, what can I do? I can take a strip of chromium and I can do a coating of chromium over this, so then it will become very shiny, right now. And why I'm not going to make this whole thing of chromium? Because chromium itself is an expensive metal. So via the process of electroplating, I will apply a thin layer of chromium over it so that it looks very shiny. Got it now? Also, chromium does not corrode easily. It does not rust just like the iron. So chromium plating will be done particularly on objects like the bicycle parts or the car parts, the taps, the gas burners, or the rim of the wheels. Getting it now? So you must have noticed down that the different parts of the bicycles, for example, rim of bicycle, wheel rims. You guys understand what is wheel rims? You understand it or not? Wheel rims on which like this is the wheel rim on which the spokes of the wheels are attached. This is the rim. So there also coating of chromium is done to give a shinier appearance and to protect it from corrosion. Also in the door handles of the cars also a coating of chromium is done on a cheap metal. That is one thing. Then jewelry makers would be electroplating gold and silver on less expensive metals, right now, to give a shinier appearance. Okay, what do you guys think that the gold jewelries that we purchase, is it 100% gold? Hmm? That's not 100% gold. Getting it, Vaika and everyone? Okay, because the fact of the matter is that 100% gold is very soft and malleable, so thereby it cannot be used for the purpose of making jewelry. Getting it now? So the jewelry that you purchase from the market always has some impurities, like it is basically some other metal over which the deposition of gold has been done. Getting or not what I'm trying to say?
Yes, sir.
Basically, thin strip of metal will be taken over which the electroplating of gold will be done. Because if you were to take 100% of pure gold, that is very soft, and obviously it will be difficult to work with a very soft substance. So there also it is used. Okay. Then the tin cans that are used for storing the food. Okay. Earlier, like particularly when food has to be stored for a very long period of time, when the polythenes were not much in use. So how the foods were stored? We had the tin cans. So we had the tin cans that were used for storing the food. But basically, it had iron in it. There was a coating of tin over the iron. Basically, there was a coating of tin over iron. Like this is the iron. So we used to do a coating of tin over it. Why? Because iron will react with the food and it will spoil the food. It can lead to spoilage of the food. So in order to prevent the spoilage of the food, we will be electroplating the iron with a layer of tin over it, because tin is less reactive than irons and it will be protecting iron from corrosion. Got it now? And the iron objects are also coated with the zinc in order to prevent it from corrosion. That is called as galvanization, by the way. You guys getting it or not? Tell me. There is one more application. Okay, no? See, the medical equipments are made up of nickels, but the contact of nickel to the body can be harmful. So thereby, a coating is done over it. Getting what I'm trying to say? Medical equipments basically are made up of nickel, right? But the contact with the nickel can be harmful to the body. Getting what I'm trying to say, guys? It can be harmful to the body. It can lead to various allergic reactions also in the body. Okay, so the medical equipments that are made up of nickels is always electroplated. Is always electroplated. Okay, in order to improve its durability and also to avoid its contact with the body. Hope you guys are getting it so far. So in jewelry making, it is used. Chromium is used to give a shinier appearance, plus chromium does not corrode easily. It does not corrode easily. Then we have the example of galvanization. Which metal is deposited over the iron in the process of galvanization?
Zinc.
That is zinc. Very good. So there's a layer of zinc over the iron. In the case of plating of chromium, basically there's a coating of thin layer of chromium over a metal object. Over a metal object. That is one thing. Then in the medical field also, this electroplating is used right now. So particularly what kind of metal is used there? What kind of metal is used there in the field of like in the medical equipments, in order to make the medical equipments? What is used? Is it the nickel or is it the copper? What do we use?
Copper.
Nickel
Oh,
is used.
nickel. Yeah.
Nickel is used now. But the thing is that the nickel is harmful to the body. The contact of nickel to the body can be very harmful right now. So thereby, in order to avoid its contact, a layer of, or basically a coating of platinum, or sometimes a coating of gold will also be done in order to prevent its contact with the body. Okay. Now you might wonder that why not make the medical equipments from iron or from steel or from cobalt? Huh? Why is it that we are preferring this only? Yes. Why is it that nickel is being preferred to make the medical equipments, guys? The main reason is that nickel is preferred material for making the medical equipments is that first thing is that it is resistant. It is having it is resistant towards corrosion. It does not rust very easily. Plus, it is strong and durable also. That is one thing. Then it is easy to clean and sterilize also. That is one thing. Getting it now? Particularly, lots of surgical tools that we see, they are made up of nickels, but has a coating of platinum on top of it. In the dental instruments are also made up of the nickels. Getting it? That is the case. Okay. So medical field, coating of gold or platinum is done over nickel. Basically, we are trying to avoid the direct contact of nickel with the body. Then tin cans that is used for the food packing, there also we are electroplating a layer of tin over the iron. So these are some of the applications of electroplating. Hope it should be clear. Any questions so far?
No, sir.
No,
Just
sir.
just give me 1 minute. Let me clean it quickly. Now, as we know that there are various other applications also of the chemical effect of electric current. So we have one such application where we can extract the metals also, extract the metal from their ores, right? So electrolysis is being used here also. Now let us understand like what is the ore. I think many of you would be aware that the metals that we obtain from the nature, they are not found in their original pure state. They're always found mixed with many impurities, right now? And it will appear as if it's a piece of rock. Getting it? But suppose, for example, if I were to bring a magnet towards the magnetite. Magnetite, you guys understand? Magnetite is an ore of a magnet. Might have heard of this, I suppose. It's an
Yeah.
ore of iron also, iron particularly, I would say. It has some magnetic properties are also there in it. Getting it? So there are lots of ores of iron. Lots of ore of iron is there. You have particularly examples of hematite. Magnetite is one such example. You have limonite, etc. All of this will appear in the nature in the form of a rock. Okay. On the first glance, you will not be able to tell whether it's a ore or it's a normal rock. So all the metals are obtained from the ores. In the process of obtaining the ores, various methods are used. One such method is electrolysis also. In order to understand this, here we are considering the example of the ore of aluminum. So we have taken the ore of aluminum ore, which is basically aluminum oxide. So that's the aluminum ore. Now we are going to melt it down first. What we're going to do, we are going to melt it down. So we have melted it so that it converts into the molten state. It converts into the liquid state. So far clear to everyone? We have taken some ore, we have converted this into the liquid state by melting it. Okay. Now take a look at this construction here. Although this question will not be asking that much of depth, but one needs to know like how this process is carried out. So we have taken this molten state of the ore, right? Then we have taken this setup in which anodes are there that is connected to the positive terminal of the battery. Then the body of this structure is itself made up of cathode basically. Okay, and it is made up of carbon which has cathode in it. Okay, and then it is connected to the negative terminal of the battery. It's connected to the negative terminal of the battery. Suppose there's a battery over here to which it is connected. Okay, now as soon as the electricity will be passed through this, as soon as the electricity is passed through this, so this electrolyte here, the aluminum ore is in the liquid state, and that is the electrolyte. So it is going to split up into its components, isn't it? Basically, this electrolyte is aluminum oxide here, no? Getting it, Ibrahim, Ramiz, and Weiger?
Yeah.
Please tell me if you guys are having any confusion so far. Please tell me.
So I can explain it again.
Yeah, sure. Okay. No? See, whenever you guys have any confusions, any slight confusion, just raise your hand in the class. Okay. No? And also don't shy away in asking the questions. See, electrolysis is being used to obtain the metal from the ores. When you look at a given ore, just take a look at take a look at the image of this bauxite. First, take a look at the image of this hematite. That is an ore of iron. 1 minute. See, this is how it looks like. That's the structure of an hematite over here. This one over here, the one which I have selected. That's a hematite. Now take a look at the example of the bauxite. Bauxite is the ore of aluminum. Okay, now the first three images are of the bauxite here. Got it, Viker, Ibrahim, and everyone?
Yeah.
Yes, sir.
Then look at the aluminum itself. Like, how does the aluminum looks like? It looks like this, right? Now, it is very different from its ore. Getting it? So we need to obtain the pure aluminum from its ore. So thereby this process is being carried out. The first step is that the ore here, the bauxite here, has to be melted. It has to be melted to convert this into the liquid state. That is the first thing. Then also this is the electrolyte basically. That molten ore will be the electrolyte. Then take a look at the body of this thing here. It has electrodes dipped into this solution, into this molten electrolyte. The anodes are dipped, and thereby this body is basically connected to the negative terminal. Thereby, this complete body that is made up of carbon will be behaving as the cathode. This thing is clear to everyone so far?
Yeah.
Yes, sir.
Good. Now, as soon as the electricity will pass through this, what is going to happen? The aluminum oxide is going to break up now. So it breaks up into aluminum. That will be the cation, and thereby another thing will be oxygen, because it is aluminum oxide now. Oxide for oxygen, aluminum, that is aluminum basically. Getting it? So oxygen will be the anion, will be anion, meaning that it will be negative and the cation is positive here. So aluminum being positive, it will be attracted towards the anode or towards the cathode. Where it is going to be attracted? Tell me.
Towards the cathode.
Towards the cathode, obviously. See, so take a look at these dots here. These are basically the molten aluminum. These are the aluminum here that has deposited to the bottom. That is sticking to the structure of this thing here. Got it, Viker and Ibrahim and everyone? Ramiz?
Yes, sir.
Yeah.
Good. And it is obvious that the oxygen will be forming around the anode now, right? So oxygen gas, oxygen bubbles would be evolving near the anode. So that is how the extraction of the aluminum from its ore is carried out. Got it, everyone? Further, there will be some other impurities also, and that will be simply left behind in this setup. And there will be a small pipe from which we will take out this molten aluminum, and the impurities will be left behind in this. So that is how it is carried. Hope it should be clear. Okay. Then we have another application, that is the purification of metals. Okay. Now see, if you have an impure strip of a given metal, right? So how are you going to remove the impurities from a given strip of metal? If I am giving you a strip of metal, and how are you going to, sorry, let me just take some water. 1 minute. Sorry for the interruption. Yeah. So I was saying that suppose if you were to be provided with a strip of a impure metal here, right? So how are we going to remove the impurities from this? Okay. For example, if impurities are embedded, basically attached to this metal, it is difficult to pick it off by hand. And there's impurities inside this given strip of impure metal also. So you cannot remove it manually. Getting in what I'm trying to say? So thereby electrolytic refining will be done. Electrolytic refining will be done. In this method, what is basically done? The impure metal will be used as the anode and a pure metal strip will be used as the cathode. Getting it so far? And as the process will be carried out, as electricity will flow in this, so the pure metal will be deposited towards the cathode, while impurities will be settling down beneath the anode as anode mud. It will be settling down beneath the anode as the anode mud. So whatever impurities were there in this now has settled down in the form of anode mud. Getting it? So let us discuss this. Ibrahim, quickly read the given paragraph.
The method of electrolysis is also used to purify a metal by separating it from the impurities. The impure metal is used as an anode, which first dissolves in the electrolyte solution and then deposits on the cathode in the pure form. The impurities of the metal remain in the electrolyte solution only. Metals like aluminium, zinc, and copper are purified in this way.
Okay, got it now? So that is the case. So for example, in the nature, the miners have found some impure metals, impure copper, impure aluminum or zinc. Huh? So it can be purified in this manner. So that is called as electrolytic refining. So let us discuss like how this will be carried out. But before that, you guys take a look at this animation quickly and observe what is happening in this. So which one has been made the anode? The pure copper rod or the impure copper rod? Note down that we are doing the electrolytic refining of an impure copper rod in this one. So which one is made the anode?
Impure.
Exactly.
Mm.
The one that is impure will be always made anode by connecting it to the which terminal of the battery?
Positive.
Observe here now. Positive. Getting it? Okay. Then the other one over which deposition has to be done. So we'll be taking a pure strip of the copper rod here that has made the cathode. Okay. Now in the process, what is happening? As the electricity is being made to pass. So look what is happening. Okay. Also, we have taken this electrolyte here, that is copper sulfate. It's an acidified copper sulfate. It has some acids in this also. So it will split up again into copper and sulfate, and thereby the copper from this impure rod will also break away. It will also dissolve into the electrolyte, right? So copper from this one is also going back into the electrolyte. That's why you will notice that the size of the anode, that is the impure rod, is decreasing. Do you guys observe in the animation that the size of the anode is decreasing?
Yeah.
What happened to this? Yeah. So it is decreasing because the copper from this is also going into the electrolyte and will deposit into the pure copper rod. And see how the size of the pure copper rod is basically increasing. So Basically, purification is done in such a manner that we are taking away all the copper from this rod, and all the copper further will be deposited into this. Not all, but some of them will be left. So copper is taken away from this, and it goes to the cathode, while impurities will deposit beneath the anode, will be called as anode mud. It will be called as anode mud. So hope that should be clear to everyone. So that was one such application which we have discussed. Okay, now so extraction of metals and then purification of the metals we have discussed. Then certain compounds can also be produced. Okay, now why the decomposition? Like certain compounds can also be broken up into its components. For example, we can obtain hydrogen and oxygen from the water, right? So the electrolysis method will be used to decompose a compound into its constituents. We have the example of water, where it can be electrolyzed. By the process of electrolysis, we can obtain hydrogen and oxygen from this. Okay, that is one thing. I'm going to show one video to you guys, but before that, you need to understand two more important properties about oxygen and hydrogen. Like, if a hydrogen gas is being given out in a experiment, how are you going to, like, it is invisible gas, you cannot view it, getting it now? So how you guys, how we can say that hydrogen gas has been released in a given experiment? So hydrogen gas, when it comes in contact with the fire, so it burns with a pop sound, gives a pop sound while burning. Getting it, Ibrahim and Ramesh? That is one thing. So if I were to bring a light matchstick near to this, so it will give a pop sound. And how will you prove that oxygen gas has been released? How can we show that oxygen has been released in a given experiment? What is the property of oxygen? It helps in burning. What is the property of oxygen? It helps in combustion, isn't it?
Yeah.
It helps in combustion right now. That is one thing. Okay. Now let us look at this given video first. Okay. So in this given video, what we can understand, like what is happening in this. We have taken two electrodes. Okay, either we can take it from a chemistry lab, or we can simply take it out from a battery, from a electrical cell, like that guy took. Okay, then what next is done? We have taken some water and we have added some acid in this. Particularly in that video, he added sulfuric acid in this. Sulfuric acid is found in the battery. So from there, he took some acid and then added in this to make it impure, so that it will behave as an electrolyte. Then as the electricity was passed through this, the water is split up into hydrogen and oxygen. So hydrogen being the cation, this is water, it is split up into hydrogen and oxygen. This is the positive ion, this one is the negative ion. Basically, it's cation and it's anion. So cation is going to be, will be forming over where? It is going, the bubbles of the hydrogen gas will be near the positive or near the negative electrode. Yes. Look at this one. This rod here is connected to the negative terminal now, right? So this rod is the cathode. So cathode will attract the cation now, since it is negative. So it is going to attract the cations. So hydrogen gas will be forming over here. You can see the hydrogen gas bubbles here. Getting it, Ramesh and Ibrahim?
Yeah.
Next is the oxygen gas. So this is the anode, this is the positive terminal, and oxygen being the negative ion, that is the anion, will be forming near this anode. Now the question is, how can we show that in which one hydrogen is being formed? Like, but it is obvious that we know that in this one hydrogen will be formed, in this one oxygen. But why, like, how can we demonstrate it? So if I were to bring a matchstick near to this, so remember what did I told you guys moments ago? The hydrogen gas burns with a, yes. How does the hydrogen gas burns? Does it produces some sound or not?
Yeah.
What kind of sound? So
Pop. Oh.
pop sound is produced. And oxygen, when oxygen will be brought near to the fire, so thereby in that video you would have observed how the flame threw away, like how the flame increased in size. Getting it now? So how the flame increased in size. So thereby we concluded that the falling gases were obtained near the electrodes. I will once again play the last part of this video. But in the beginning also it is visible. 1 minute. See, from here you guys observe. Okay, let's play it from the beginning. It's not working. Ibrahim, turn your camera on in the class. Okay. Then we have another application, that is the production of compounds. So new compounds can also be produced from this. Okay. So for that purpose, I have taken one such example here. I'm going to describe it, but nonetheless, you just need to memorize that why the method of electrolysis, production of some compounds like sodium hydroxide can be done. Okay. So let me just explain to you how it will be done. See, we have taken the salt solution has been taken here. Which one has been taken? A salt solution. Basically, the sodium chloride solution has been taken. It's the common salt that we consume. It's the common salt that we consume. Then we have taken two rods here. Okay. When electricity will be made to pass through this, by the way, the rods are connected to the battery, obviously. So when the electricity will be made to pass through this, okay, then what is observed here? That chlorine gas bubbles would be forming near the positive electrode, that is near the anode. And near the cathode, the hydrogen gas bubbles would be forming. And sodium hydroxide solution will be later on forming in this given setup. That is here the hydrogen gas. So why the method of electrolysis? Production of new substances are occurring in this one. What kind of substance? Particularly, we have sodium hydroxide solution that is being formed in this one. Getting it? So what basically happens? We have the NaCl solution. This is the NaCl solution, NaCl, you guys understand now? That's a sodium chloride. Okay, that is the sodium chloride solution we are having here. Let me write the word sodium chloride. And this here is our electrolyte. This here is the electrolyte. So when electricity will be made to pass through this, it is going to split up into its component, right? That is, it is going to split up into the sodium plus chlorine, getting it, plus chlorine, getting it so far. Sodium is given out, chlorine is given out. Chlorine gas will be forming near the anode. Okay, while hydrogen gas is also given out in this experiment, so it is forming near the cathode. While a new compound called as sodium hydroxide will also be formed. So basically, this is a chlor-alkali process which we'll be learning later on in the higher classes. I'm just trying to give a small introduction to this topic. So why the method of electrolysis? Certain compounds like sodium hydroxide can also be prepared. So that is the case. So here we have done the revision of this chapter. I have taken some questions which you guys are going to do. If you guys happen to have any questions from the chapter, please let me know.
Sir, I have a doubt.
Yeah, tell me.
In my textbook, for electroplating in my textbook, it said that the material to be coated with a layer is used as anode. So can we interchange it?
1 minute. You're saying that the metal that is used for electroplating is taken as anode.
Yeah.
Obviously, we have taken it as the anode here also. See,
Mm.
the metal that is used for electroplating, that is taken as
Okay.
anode by connecting
Yeah.
it to the terminal.
Okay. Okay.
Okay. See, and in the case of this one, in the purification of the metals, here the thick, here the impure metal has been connected to the positive terminal. So here we see that the impure metal is taken as the anode. So in the process of electroplating, the metal that is used for electroplating will be made as anode, and in the process of electrolytic refining, the impure metal will be made as anode. Okay, now don't get confused in this. Okay.
Okay.
Any questions from your side, Ibrahim?
No,
Okay, let's do these questions then. The previous questions we have already done while the chapter was going on, so I have taken some different questions. Yeah. You guys can answer it in the class. We are not left with much time, so we are going to do in the class only. So first question is, when an electric current passes through a conducting liquid, it causes a conducting liquid is given here. Is it magnetic? Is it heating? Is it chemical?
Heating effect.
It's a conducting liquid that has been given here. Conducting liquid means that it's electrolyte. Okay, no? See, questions can be framed in different manner. Here it's a conducting liquid. Conducting liquid basically means an electrolyte. No, electrolytes are the conducting liquids. So when it is passed through an electrolyte, so what happens? Does it
Uh,
causes a heating effect? No,
Heating effect or
no, it's chemical effect mainly. No, slight amount of heat will be given. That's a different thing. But the main thing which we have discussed, and the main thing that will happen, that's the chemical effect. Now there will be evolution of gas bubbles. There will be deposition of metals or color change. All of these were the chemical effects. Got it?
yeah.
Okay. Next.
Lemon juice.
Good. Ibrahim, you also have to answer. Third one. Is it true or false?
True.
true.
It is true. As we know that tap water has lots of dissolved mineral salts in it, right now. So tap water is impure. It has dissolved mineral salts in it. Thereby, it is a good conductor. Okay. That is the case. Continue with the next. You have to define electrolysis and give an example of its use. Both of you have to define it. By the way, you guys understand about TDS now, total dissolved solids in the water. One should ensure that the TDS levels does not rises very much. If the TDS level in the water rises, the water will be tasting salty, will be tasting bitter or metallic. Okay, no? Okay. And like if suppose, for example, there are scaly deposits on the buckets, so that shows that it means that the TDS level of the water is very high. And if you are consuming, someone is consuming the water that is having high TDS, it is harmful to the health. I suppose you guys are familiar with that, this term TDS level, right? Like whenever you get an the aqua, what do we say, aqua filters installed in the house, so the technician will ensure that the TDS level is correct. The water that is being released from that, its TDS level is correct. Particularly, kidney stones is one such major problem that can occur if the TDS level is high. Anyways, let's get back to this topic.
Electrolysis is when an electrolyte splits into its constituents.
Okay. Give one example.
And copper sulfate is broken down to copper and sulfur.
Okay. One more. Yes. You have the okay. Ibrahim, you continue then.
Question number 4, right?
Yeah. Question number 4.
Electrolysis can be used for electroplating.
No, I'm not asking about application. I'm asking you to define it. What you understand by this? Okay, let me help you out then. See, electrolysis is basically an effect in which chemical decomposition of a given conducting liquid occurs when electricity is passed through it. What I'm saying that it's an effect in which chemical decomposition of a given conducting liquid occurs when electricity passes through it. Chemical decomposition means that it is splitting up into its components. Okay, for example, the electrolysis of water. When electricity is passed through that water splits up into hydrogen and oxygen. Okay, you had also one such example as you given. When electricity is passed through copper sulfate, it splits up into copper and sulfate. So that is the case. Got it, both of you?
Mm.
Yes,
As
sir.
an example, you can quote the example of electrolysis of water. You can always remember this. Yeah, answer the last question. No, there's one more question. There one more set of question, by the way. Yeah, answer this one. Copper sulfate.
A solution.
A solution, good, basically. Next.
Used in electroplating.
Good. And anode is the
Positive electrode.
positive electrode. Okay. So that's it. So that's it for today's class. You guys let me know which chapter you guys would like to begin next in the upcoming classes. We have some more questions that we will deal with in the next class.